be here. I wanted to join you in the field when Monique first asked me about this event. I just wanted to be part of it for the whole thing. I'll give a little bit of background. I'm a fire ecologist and have studied field treatment effectiveness now for quite a while, partly because I live full-time in the Methow Valley, and we've just had massive wildfires around us, as many of you now have too. But back in 2006, I was just like 2 years into living in Eastern Washington, and we had this really big wildfire called the Tripod Fire, and I got to study it right here from the Methow Valley with a large crew. We put in 400 monitoring plots and really looked at how especially trees fared following the Tripod Fire in thin only units versus thin and prescribed burn versus controls. So I'm going to share some of that. Just I felt like it was great to talk a little bit about what I've learned over the years about burn severity and how we actually assess it, both from satellite imagery as well as on the ground. And so when Monique and I talked, we kind of sketched out a presentation that I'd give that dredged up old field plot data from way back when. So I will go ahead and share my screen. I'm a little nervous because I was hoping to not have a flicker. So we'll just see how it goes here.
If it helps, it looks great on our end, Susan.
I'm so glad. So we're just going to do the presentation view for a second. And get down back to the first slide. I don't know why I went there. There we go. Great. Everyone see this okay?
Yep.
Okay. Well, perfect. So I'm going to try to do one more thing just because it's on me. I know what I'm going to do. Great. So
Yeah.
we're all good? You can see okay?
Well, it's still in like your view, not slideshow.
Just a second. It did not work. Sorry about that. It turns out that my speaker is on my monitor, which I tried to turn off, but I think you guys are seeing okay, and I'm just going to deal with some annoying Zoom issues at the moment. So without further ado, I'm going to start and just let you know that I would have been able to go to the field had it not been for a trip that I just got back to in Georgia, where we're actually looking at fuel monitoring there. And so I have to be at my home office this week because of that. So this presentation I'm giving is definitely in collaboration with my close colleague, Gina Kova. She just finished her PhD at University of Washington and studied landscape patterns of burn severity in recent wildfires in Washington State. So she's actually kind of a mastermind now about burn severity research. And I asked her if she'd be willing to share a few, well, actually 9 hot off the press slides that just kind of give us a context, I think, when we're looking at monitoring trends in burn severity or other burn severity products, what they mean and how we can interpret them first in a landscape view. So let me see if I can actually get my slides to advance. I'm having a lot of technological difficulties, sorry. Let's see. I am going to need to unplug from my monitor. I'm so sorry, you guys. It's just not letting me advance slides at all. So
That's okay. Take your time. Don't stress. We're all a very casual group here, so do what you need to. While you're doing that, I'll just ask, does anyone have any questions from yesterday or about the field days if you're going to the field days tomorrow? You should have received, if you're going to those, either one of them, you should have received emails either from Monique or from me. If you have any questions, just please put them in the chat or raise your hand or just unmute yourself and ask.
Autumn, whenever you're ready, I think I finally got my computer to behave. So
Yep, it looks great. We've got the
okay.
the big screen, the front slide showing on our end, so it looks good.
Awesome. I usually navigate this pretty smoothly, but something happened today. So, all right. So starting out with some of Gina's slides, wanted to talk with you that, many of us are going into post-fire environments, and kind of seeing a view like this is really, I can actually see this view almost outside my window right now, from the 2021 Cedar Creek fire in the Methow Valley. But, as we're driving, we're definitely noticing tree mortality and other fire effects up close and personal. But many of us actually start out with our monitoring using satellite imagery. I know that this is review, but I thought that these images were really cool that Gina provided, showing pre-fire Landsat TM 2020 imagery from the Schneider Spring Fire outside of Natchez, and then post-fire. And as we know, the spectral indices that we use are a differencing of those two. What Gina's been doing with burn severity mapping of late is actually taking composite images from summer, say 2020, and then cloud-free images, and then composite cloud-free images from post-fire, 1 year post-fire, and getting a difference in reflectance. And so, as many of you have seen in these maps, it kind of looks like this. Gina chooses, I think because of just a color palette, to do unburned very low in blue. Sometimes that's in green. And then here she's showing low in green, moderate in orange, and then high in dark red. And I apologize for those of you that might be colorblind. But one of the things that she just presented to DNR that I think is really important is that ideally we're not just like thinking about a change in reflectance and classifying that reflectance into high reflectance, moderate, low, and unburned, but also calibrating those metrics to something that we've already measured on the ground. Probably many of you have measured composite burn index plots. I think that there's some of the most frustrating things to measure. Well, we can talk about that afterwards when I give this present, after I'm done with the slides. But composite burn index basically asks you to do some differencing at a plot level. And what I mean by frustrating is that sometimes the form is asking you to talk about pre-burn shrubs when they're all burned. And so you're kind of like guessing on some of the burn severity at that level. But we've found that actually, even though CBI is one of the most frustrating and subjective things that I've done in my career for fieldwork, there's still really high correlations with spectral imagery, and it gives you a better calibration to what these imagery like differences mean for on the ground. I wanted to just share some of the work that Gina's been doing for Washington Department of Natural Resources to kind of think about like how we dish out imagery. And so what I'm showing here is basically the equivalent of ravage. So it's immediate differencing of pre and post fire imagery. So the post has to be within 45 days following a fire. And what we see here is like a big swath of high severity fire in the Cub Creek 2. 1 year, what a difference is still showing quite a bit of high severity. This fire really packed a punch, especially along this 8-mile road here. But you're noticing that there's actually a little bit more moderate severity than the 1 year showed. What Gina's been kind of like looking at is that where areas are non-forested or really open before a fire, they will show up as high severity immediately after the fire because there's this blackened earth, a big change in reflectance. But as soon as green up happens, say in wet meadow areas or grassland, or even in open forest with like a grassy understory, 1 year later, that can show up as a very different consequence for fire severity. So I'm pointing this out just because as we're taking these image differences into considerations, there's some complexities that we need to kind of like account for to interpret where forests really burned hot, and if areas were non-forest, that's a very different severity. I'm sure you guys are talking about that, but I just wanted to share it. 2 year gets really tricky. So by 2 year, I've actually recreated in this area, so I know it well. A lot of this original high severity patch was closed canopy forest. And so 1 year, we're starting to see a little bit of green up right here. I hope you can see my mouse. And by 2 year, there's been so much green up in the understory of this high severity area that it's no longer showing up as a high difference just because there's been so much infilling of understory vegetation. So kind of complicated to think about the fate of forests from satellite imagery. Here's a little bit more showing, if I zoom into Schneider Springs fire, this area was classified immediately as low severity. And then we start seeing these patches of higher severity. We think this is real. We think that this is a closed canopy forest. She's also got a different kind of metrics on that to know whether the forests were closed canopy, open, or non-forest. This area was closed canopy. And what we're seeing is that originally it doesn't look like a lot of mortality, but over time, quite a bit of mortality is happening in these areas. So we can kind of monitor that. And then there's, as I was describing for the Cub Creek 2 fire, this was probably a high severity patch, shows up 1 year as high severity. By 2 year, not many people use 2 year differencing, but we can caution against it in this case because it's just showing a lot of green up. So a kind of fuzzy slide showing high severity area surrounded by green meadows. And so depending on when the satellite imagery is taken, you know, that green really shows in images. Here's this one more slide. We've got an area in Schneider Springs that we happen to know burned pretty hot. And what Gina's also been doing with her study, and I'm happy to kind of like get you guys in touch with her if you want to learn more, is that she's pairing sometimes with National Agricultural Information Program imagery or NAPE imagery to look at where she really can see with these red crowns areas where indeed delayed mortality has happened. So satellite imagery, I think the punchline is a great first step, but it can't just be the only step. Like we're really needing to put on our detective hats to better understand the imagery and what it means for delayed mortality. Here's just one more NAPE image, this time taken in an area that actually wasn't closed canopy forest before. And with the NAPE imagery, you can see some brown crowns, so probably delayed mortality, but that signal is really washed out by the rapid greening of areas that just aren't closed canopy forest and so ready to green up quickly. So with that, I just thought those slides were really cool, and she just gave a presentation to DNR, so I borrowed them. But now I'm going to go way back in time to 2007 when we started this study. So I live full-time in the Methow Valley. I'm sure many of you know where it is. I probably should start out with a map, but I forgot to do it. But anyway, this large wildfire occurred just north of town. And we lived through just the worst smoky summer. The smoke started in July and didn't really disperse until October. And so when I put together this study and applied to the Joint Fire Sciences program for it, it was more about like, wow, can we learn from this wildfire? Because it was really hard to live through. And sure enough, the Methow Valley Ranger District had done a lot of treatments in this area. We're seeing a little bit of one right back here. It's a thinning unit. And I just wondered, like, can we actually do a retrospective study to understand which treatments worked and which ones didn't? At the time, there's a lot of conversation about whether we could use thinning as a substitute for fire. And this was one of those studies that had a really robust data set that definitively said that prescribed fire is the better tool. So you guys probably already know that, but I'm giving you the punchline. So here's the picture of the tripod fire. It was nearly 200,000 acres in size, which back then seemed like a really big deal. And I knew that there were treatments in the lower part in the Methow Valley Ranger District. So these black hatch marks that I'm showing here are past treated areas. They do extend beyond the tripod, but we buffered them in GIS to just kind of be clipped within a ½ kilometer of the fire to evaluate their effects. And if I can take you right here, the tripod complex started in 2 places The Spur Peak fire started right around here with the old 1970 Forks fire. And then the tripod fire started with this really big sea of dark red. So it was wind driven, and you probably can't see it necessarily on your screens, but I zoomed in here. There were conspicuous areas of green within this wind driven patch of high severity. And sure enough, those patches are either past shelter word cuts or thins, or even past clear cuts that had broadcast burning. And so we kind of knew that from satellite imagery, and then based a field study to investigate further. So I've taken scientists from different parts of the world out, and especially immediately following the tripod, there was some kind of jaw-dropping disbelief about what we saw in terms of the effect of fuels on fire patterns. And so these are just some of the pictures. I was seriously with this one guy from Spain, and he's like, this is not possible. Those trees should have burned. So I thought it would be kind of good to share these pictures with you, because you are all discussing fuel monitoring, and I was able to monitor those fuels and also look at kind of fire effects in this study. So what we see here is an old clear-cut block. They used to do more of that back in the 80s in the tripod area. And this had been broadcast site prep burned, like site prep burned or broadcast burned. It just meant that they took a prescribed fire and had a continuous burn through logging slash, and then planted Douglas fir. There's some lodgepole pine in here too. But even 20 years later in the tripod, fuels are so discontinuous in at least this instance, that a wildfire that burned often as a crown fire, but also as a hot surface fire, didn't even touch this unit. There were just not enough fuels on the ground to carry fire, and the trees survived. That's what it looks like in the top right too, is just kind of the sea of really high severity fire, and then this inconspicuous island of green. I wasn't as interested in clear cuts. I've never been that excited about them. So I studied thinning and prescribed burning. And this is just kind of a view of what we were looking at. I didn't do a lot with surface fuels. I could have, but we were really pushed for time to try to get in a robust sampling. And so we did have over 400 plots, and we're mostly considering tree mortality for this study, as well as beetle attack. So the design was basically to find 8 randomly placed control units that I made in GIS to be kind of around the same size as thinning and prescribed burn units. So they were randomly selected, and we went out and measured tree mortality and other things that I'll just now unpack in next slides. And then we had thin only units, and then thin and prescribed burn units. What I'll say is that when we were doing our monitoring on the ground of looking at scorched trees, looking at fire-killed trees, in many of the prescribed burn units, because they'd been done in the last 15 years prior to the tripod, we felt like we were actually taking measurements about the prescribed fire effects, and suspected very strongly that the wildfires didn't even burn these units, in many cases, just because the fuels were so discontinuous. That was not the case for any of our thin only units. They burned really hot. In fact, we found in some of the areas, especially where they had they called them sanitation cuts, where there was piled small trees, that we saw even more severe effects in the thinned units than we did controls. That said, this picture is really representative of the thinning units, where you'll notice that the trees have red needles on them, showing that they were scorched, so killed by the heat of the fire, not actually burned. Whereas in a lot of the controls, not all, but many of the controls, they were denser and more prone to crown fire. And so you're seeing this difference in lack of needles for the most part in controls, and more black. So the trees are actually blackened by fires actually burning into them. There was my thin unit. I was wondering where the label was. So in terms of our sampling design, we really focused on low to mid elevation stands that had Predominantly ponderosa pine and Douglas fir. There were some subalpine fir, lodgepole pine, but we wanted to be in an area where thinning was appropriate for our study. And then the harvest units, some of them were tiny, like 3 hectares in size, up to about 42 hectares. So this was really an opportunistic study. And we made sure that the thin and prescribed burn prescriptions were pretty recent, so the last 10 to 15 years. Because we were worried about like sample size with only having 8 controls and 8 thin and 8 thin and prescribed burn units, we also looked at adjacent controls. So here we have our thin and prescribed burn unit here. And then this is what the forest looked right next to it. And so once again, I think what we described in the previous slide is definitely to bear. You can see here, this was 1 year post wildfire. We didn't know if the wildfire burned into this site, but we suspected it might not have. And then right at the edge, this control unit wasn't a crown fire, and we know that because the trees still have their red needles. So here's just a description of what we measured at each one of the plots. And so we visited the plots for the first time in 2007. For any living tree, we actually tagged it at the base, and we had a GPS unit as well as rebar in the center post that we then used to come back in 2008 and 2009 to sample living trees again. It was interesting because we thought we did a really good job on live versus dead, but during the summer of 2008, we did find some Western larch and ponderosa pine that we call Jesus trees because we thought they were dead, but they came back to life. And so we like marked those as live and corrected our data sheets. And then for each tree, we'll kind of get into some nice diagrams so this isn't so boring. We wanted to understand at a tree level metric what the wildfire did to it. And again, when we're in the thinning and prescribed burn units, these metrics might have actually been the prescribed fire. We couldn't tell. So the first set of measurements we did was a minimum and maximum char, so the blackened on tree boles. Oftentimes the char height is higher on the uphill side of a tree or on the opposite end of where fires are spreading. And I'll describe that a little bit in a better diagram. Height to live crown, as well as height to crown base, so that we're kind of like reconstructing what the crowns used to be and then what they were after fire. Very closely connected to the maximum height of crown scorch. And then we found this burn severity index that was created by the Park Service to be pretty helpful, where we had a 1 to 5 ranking on whether the tree was just unburned completely at 1, scorched, actually 3, partially consumed at 4, and then fully consumed by crown fire at 5. And then our most frustrating measurement that we took was percent crown scorch. So we estimated of the crown volume, what percentage was burned. And if any of you have argued with your colleagues about percent cover estimates, you can imagine we argued a lot about like percent crown scorch. I believe very much in taking the best data possible with crews. And so we would play a percent crown scorch game at the beginning of the day or week so that we could all calibrate and hopefully not institute a lot of variability in our estimates. So I quickly looked up, I'm sure that you're doing more with this group, but Sharon Hood always has amazing documents. And so she has this one from way back. I think that this actually was from 2017, but it was updated maybe in 2024. That just gives a guide to post-fire assessment of tree status. And so here quickly we're seeing, I think that in this diagram, a fire would have been coming, and probably wind would have been coming from the left, and minimum char height is where it first encounters the fire. And then fire works a lot like water flow. And so if you imagine like a river eddy, the fire had to break at this tree stem, and then wind and heat eddies on the leeward side of the tree, and that's where we often get the maximum char height. So min and max bole char height can be important for thinking about susceptibility of trees to dying from fire, but they're also really helpful for thinking about directionality of fire and being detectives that way. Here's I did a screen capture of their guide, so it's a really bad photo. Sorry about that. But it shows here, this is the height to crown base. And if you look closely at this blurry photo, you do see some kind of patches of uh, scorched needles here. So I'm pretty sure that this was the original crown. And so you've got the dead before fire, and then this was the pre-fire crown base, so we're calling that height to crown base. And then we would go all the way up to here for a height to crown, a live crown. So pretty helpful to kind of understand how much of that crown is still living. I'm not calibrated with my crew right now, but I would say that when we were thinking about percent crown scorch, we included blackened within that because like that's the ultimate scorch in terms of like how much of the crown was impacted by fire. So we wrapped in blackened plus the red needles to estimate the percent crown volume affected by fire. And right now I'd probably say if I had to guess, that looks like 50%. I probably wouldn't do any more than that, but people might, we might have to argue about it. Here's just another kind of showing of how over time you can monitor trees. And this is maybe really helpful if you're looking at dynamics with bark beetle outbreaks too, as I know Sharon Hood often does. But here we're actually seeing a tree, ponderosa pine, with initial post-fire damage. So a lot of needles are either yellowed or completely red and killed by this fire. Ponderosa pine and larch are pretty awesome trees. And so in this case, 1 year post-fire, we are seeing that the individual branches of that ponderosa pine had preserved buds that were able to shoot out new needles. And so individual branches came back. They weren't outright killed. The needles were killed, but the crown recovered. That would not be the case in the case of a crown fire into either a tree top or a tree branch. And here we're seeing the difference with blackened needles. Little bit of charred needles here, but you can see that most of this crown actually consumed in the fire. So I'm going to move on to just a few results of this study. Might be the cleanest statistical study I ever do in my career. What we found was just so definitive. So if we're including all trees, even down to tiny, like I can't remember diameter cutoff here, but this would be all trees of small up to large diameter trees. We found that in the thin and prescribed burn units, 50% of the trees actually lived. So sorry, I forgot to do the correct label here, but this is percent live. And only 12% or 12.5% of the thin only trees survived and only 8% of controls. And so when we look at that with statistical differences in ANOVA, there was no statistical difference between control and thin only units, and really high significant difference between thin and prescribed burn and the other treatments. When we looked at large diameter trees, this is pretty cool. So the larger Douglas fir, ponderosa pine, larch survived really well. And so over 75% of them survived in the thin and prescribed burn units. If I were to do this study over again with ample time, I would have definitely included prescribed fire only. Anecdotally from satellite imagery, we saw that prescribed fire was the ultimate treatment that worked. And so if I had a fourth treatment, I think we'd see that it was very similar in effectiveness as thinning and prescribed burning. So as it turned out, after a lot of grief about trying to calibrate with percent crown scorch, it was our best predictor of tree mortality. And so here we have over the 3 years that we monitored these treatments, we saw that basically the thin and prescribed burn units just had really significantly lower crown scorch than control and thin units. Interesting, because control units are dense and more prone to crown fires, but the thin units had so much like deferred fire on the ground from fire explosion followed by thinning and logging slash, that even though they didn't show any evidence of crown fire, they had really high scorch because of the heat of those surface fires. Here's just another kind of view of data. It was kind of fun for me to go back to these older papers, but here what we're seeing is a time series, a short one, of 2007 in the dark gray, 2008 in the lightest gray, and then 2009 in the farthest right of these. And Grand Fir definitely showed highest mortality and then a drop-off mortality, same with lodgepole pine. Interestingly, I think this is super cool. Larch had really high survivorship. It's such a fire adapted tree, and just very little delayed mortality. It was our lowest sample of trees. We didn't have as many as ponderosa pine and Douglas fir, but we were not surprised to find that result. Ponderosa pine had much higher survivorship than Douglas fir. As you might imagine, it's more fire adapted too. But you'll notice that we did detect this kind of pattern of delayed mortality. Some of that was bark beetle activity. And then Douglas fir, even more delayed mortality. And sure enough, we had a Douglas fir bark beetle outbreak in the area that definitely we saw a lot more Douglas fir trees dying in the second and third years of sampling. Almost done, just with kind of cool analyses, but these are basically looking at predicted probability of mortality in our different treatment units, and control have basically the same curve as thin only, just a little bit higher predicted mortality than thin only, and much less with thin and prescribed burning units. And these are diameters. I'm so sorry I pulled off this. But it's basically showing a relationship with tree diameter too. And then here is 2008, much less mortality overall, as we would imagine that second year, but same trends. All right, and then this is kind of cool too. So probability of beetle attack, much lower in the thin and prescribed burn units than the control. And then interestingly, our thin units with all of that slash and deferred fire actually had the highest predicted probability of beetle attack, even more than controls, which I thought was kind of fascinating. So with that, I wanted to give us a little bit of time for questions. So I'm pretty delighted with my end time, and I will stop sharing.
Thanks so much, Susan. Great presentation.
Great.
Does anyone have any questions? Feel free to just unmute and speak up or put them in the chat, and we'll give it a second for that.
Hey, Duncan.
Hey, Susan. So this, I don't want to go down the rabbit hole, but, with the recent sort of change in maybe I'll just put it this way, in the Forest Service, the desire to cut more trees.
Yeah.
We have one person locally in particular who's saying, well, that just causes more of a problem with fire, because all it does is, we get more sun on the ground, it cures out the fuels and it grows all the herbaceous veg in there. And then it's just a lot easier for the fires to burn, to get started. And, I think that people who are firefighters know that those fires in those systems are much more controllable. But I'm just wondering if you have any sort of a response to that, if somebody were to say that to you. And I look at this, the information that you have, which sort of shows that actually no, that the stands that had some treatment didn't burn, even though everything around it burned. And so I just wanted to get your input.
Yeah, absolutely. So, I think that cautionary statement is sometimes true. Like I've gotten to talk with you enough, Duncan, where, I know that you and I both understand the power of place. And so if we were in temperate rainforest, like the Hoh rainforest or Amazon rainforest. And there was a lot of thinning, and that thinning came down onto the forest floor as dead wood, and you had more open conditions. You can make the argument that you've actually increased fire hazard. Like you could. I think that one of the reasons why that argument breaks down where I live and where you live too, in many parts of the interior West, is that forests from the get-go have a long window of time during the summer fire season in which they're pretty flammable. And so that's the case when they have a dense canopy and when they don't. And so we then need to think about mitigating the risk of those forests. And so I think that we all kind of recognize that in the absence of fire, we kick that proverbial can of fuel accumulation down the road every single year. And in deciding to remove fire from a system, we are, especially in fire country, predisposing this forest to high severity fire. And so that literature now is so mature that I have no question about it. And when I talk with the media, I don't even engage in a controversy just because the science is so clear now. And I don't have to pick a fight. It's just I can actually kind of cite the science at this point. So the work that all of you are doing in terms of fuel treatment monitoring, I think builds really necessarily on what we know in the scientific literature and gives that sense of place for community and also much more place-based knowledge. So I think it's really awesome that everyone is continuing to do field treatment monitoring.
Thanks.
Hi, thanks so much for that presentation. That was really fascinating. I have a couple more like logistical questions when it comes to assessing severity, and I don't know, maybe it's something we'll be covering later on today. So if it is, feel free to defer me to that. But one of the questions I had was when you were collecting data on these trees, all these different metrics, I imagine that you did it on sort like you had like plots within a certain radius, and what size trees kind of did you take all those assessments on? Did you have a certain diameter cutoff? How did that work?
Yeah, I'm super happy to get you our paper where we cover that. I struggled a little bit with the plot dimensions because in reality, some of the thin units that we were working with were more like shelter woods where there just weren't that many leaf trees. And so we wanted to make sure that we kind of had enough trees in order to calculate percent mortality. And so for the thin only units, we ended up doing a half acre. I think it was, sorry, it's weird that we do half acre when we're doing kind of like metric system otherwise, but that's what I remember it was. Whereas the control units, we actually had a smaller radius, and I don't remember what that was, but it kind of killed me to do that. But we were just going to get way too many trees in the control units if we had the same plot size. And we thought about using prism plots too.
No, that totally makes sense. I think that's what we run into. Kind of the opposite is we have a lot of trees and we start taking tree data on all these trees, and then we're out there for 4 hours per plot and we're like, this isn't going to work very well. So that's why I'm asking. Thank you. And the other thing I had a question about was, so there's a few of those metrics that I would love a little bit of clarity on the difference between some of them. Like for instance, when we're looking at height to live crown and height to crown base versus crown scorch height versus percent crown scorch. And it makes me wonder if some of those things can be calculated from something else, like, we're talking percent crown scorch. Is there a reason why you take those separately versus just saying like, this was our height to live crown before the fire, this is a height to crown base, so from that we can calculate percent crown scorch?
That's such a great question. And I do wonder because like this study is pretty old now. I wonder if Sharon Hood and others might have some better suggestions than me, because they've been doing more on crown metrics and relationship to tree mortality. And so it would be wonderful to invite her to this if she hasn't been already. Monique, I don't know if she was on the roster. I saw Duncan, but yeah.
No, but yeah, I'm putting down some notes for next time.
Yeah, totally. And so Alina Kanzler and Helen, I'm super happy to put you in touch with both of them. They're super accessible and they would be who I would contact if I were to do another study. But I will answer based on what we struggled with. And that was that I do not like subjective measures. I have a really hard time with them. And so when it came to that index 1 through 5, it was a little bit like, 3 is 100% crown scorch. I don't like that. And then 5 is all charred, but there was just like too much wiggle room with that index of 5. And then for the percent crown scorch, I'd read the literature and I knew that it was a strong predictor of tree mortality, but I hated that our crews would have to continue calibrating to make sure that they weren't just like instituting a lot of crew to crew subjectivity with that measure. So therefore, we had our range finders, and I loved the idea of being able to have more distinct measures that were things we could absolutely measure. And so that's why we did so many, was I was hoping they would be analogous enough that if we totally messed up with our percent ground scorch, we had something else. So
Awesome. Thank you.
Susan, this is Heather. Hi, Susan.
yeah. Oh, hi, Heather.
I did want to just let you know that I shared your video for FFI or FFT, sorry, FFT yesterday.
Awesome.
And are you going to be on for this next session?
I can be. I've got to check my calendar because I saw you were talking and I was like, ooh, I was just in Georgia doing field work all last week, so I'm a little bit slow to the agenda. But I would, yeah.
I know way less about this than you do, so I would much rather have help facilitate a discussion. If you're able to hang out, that'd be great.
That'd be really fun. I just don't get to hang out with you enough anyway, so yeah. Okay.
Yeah, I do have some additional questions that, I mean, part of that, so there's a video that is for this next bit to watch, and but then there's a lot of questions that might come up that I might not know answers to because I don't do this as much as you do.
Yeah.
So yeah, I wanted to catch you before you went away to say that you would be.
Okay, sounds really good.
Sorry, I throw my fire emojis around once in a while.
Awesome.
I was going to say, so Susan, you're one of those rare scientists that's really good at communicating science to the public.
Oh, thank you.
That's my perspective.
Yeah.
So with some of these, I feel like there is going back to what Duncan Lutz was talking about with just how, and I have gone out in the field with you where we've talked with some folks that make some of these bigger, higher level decisions. How do you communicate some of these? We're supposed to be monitoring and just unbiased showing the effects of our treatments, but at the same time, how do we look at these things and make sure that we're not telling this, or we're not leading people in the wrong direction? One of those was a monitoring project I was working on, and we were talking about thinning with tribal members, and a majority of them didn't want to answer the question until we clarified what type of thinning are you talking about, and because this is really changes how I'm going to talk to you about the benefits depending on what agency's doing it, how they're doing it, and like whether it's commercial or pre-commercial. And then and we don't have to go too deep into this, but another thing I was thinking about was crown fires and how far they can carry. And if you guys have looked into whether or not the benefits, how much the benefits actually make a difference of a thin and burn with some of these larger fires. Do they even make a difference at all after a certain size, and during
Yeah.
certain times of year? So
Those are all
anyways, those
great
are some heavy
questions.
questions to ask, so feel
No,
free.
I'm aware that it's 8:55, so I'm technically 5 minutes over my allotted time. I
Oh, my
desperately
bad.
answer those questions, so if I'm allowed to have a little more time, I will, but I also want to allow my colleague to have her time.
I think
So.
you should take that question. That's great.
Is that okay?
Yeah, totally.
And Autumn,
Yeah.
if we need to move forward, we could always push it to a different time. Sorry about that.
Oh, no, I think that's a great
I
question.
personally think, I don't know, folks, feel free. I mean, you're the students in this, so it's for you all, but like, I personally think that we can be flexible. I think the folks who are going to be on today are on here. So if we're having a great discussion and we have to shorten like the video at the end of the day, I would prefer to do that. Because it's, I feel like this is such a great opportunity to have like all three of you powerhouses on here, this power team of like Susan and Heather and Duncan. And so like, let's take advantage of that and not worry about the time so much. That's my take.
Okay, well, that sounds great. And I'll also try to be really quick with what I'm saying because Monique was actually describing how in the previous administration, who I'm missing very much right now, we were able to go to the field together and talk with people from the White House, Council for Environmental Quality, as well as Office of Management and Budget, and about field treatments. And so how do you kind of distill down truth? You know, it's really important to me that as a scientist, I'm sharing evidence, but also what we can now advocate for based on what we've learned. And so what I have come to is that I want to make sure that people understand that we're never one and done with fire. Well, wildfire can come through and there still might be a necessity for fuel reduction treatments and certainly a necessity to continue bringing fire back to a fire adapted ecosystem. So that's one. The second is like effective. How is the treatment effective? And so I think that one of the things that I've really been emphasizing of late is that all treatments can reduce fuels, but they can also rearrange fuels. And so thinning can reduce crown fuels. And we saw that really effectively in the tripod fire, but it can reallocate them to the surface, as you all know from your fuel monitoring. And so getting that across that there's a rearrangement, not always just a reduction, is important. And also that fire does the same thing. So fire reduces surface fuels for a time, but it can also recruit fuels in terms of killing trees and having those trees fall down or shed branches. And so that I think has helped explain to people at all kind of levels of management, and they probably already know this to some extent too, that it's not one and done. Like we can have a prescribed fire that reduces fuels, but also creates more fuels. And so this maintenance aspect of monitoring and communicating is really important. I didn't answer your second question, Monique, about why do thinning and burning, like if you're going to have a massive extreme wildfire. And I would say that if we're at tiny postage stamp treatments, they might work at that postage stamp and in a tripod. That was really important for seed source. So that's one why. For broader negative feedback to fire size and severity, I think we need to start thinking about larger treatment spaces, but then they really do work because they're reducing the energy of that plume and the energy of the flame lengths into the adjacent stands. So we're not there yet, and it's hard to imagine, but we can be because Indigenous people have done that for millennia. So
Thanks, Susan. I was just putting some good arguments in my pocket for later
Love it.
because sometimes people will ask that. They'll be like, you do all these treatments and then you see these, huge fires get carried through the crowns. And so, we need to figure out how to tell our story better about how even though you are seeing these large fires, there are still benefits to what
Yeah.
we're doing. So just big sell for monitoring and what you're doing.
Awesome.
So I appreciate everything.
You bet. So I'm gonna need to dive off and I will come back, Heather, if